So what we'll do today first is to talk about the homework assignment and then the question number 4 of the practice exam. For those of you who kind of checked out the 10:30 class, that question was actually covered already in the 10:30 class, but I forgot to record the solution for this particular class. So we'll go ahead and do all of that stuff. If we have time left, we'll start to work on local variables in the notes. Okay. Are there any questions?
Yes.
Good. Go ahead. All right.
On the homework.
Okay.
Well, once you pull it in.
Yeah, we'll definitely do the homework too today. But if you have any specific questions about the homework, make sure you ask those questions when we go over the homework assignments, because that's really important. All right. So let's see. Where's my browser? Let's get started. So did you guys change all your passwords because of the hard bleed issue?
What?
Yep, most people did.
The what?
The hard bleed problem. I kind of mentioned that before the break, maybe not in this class. It's a security issue that affected 500,000 websites. Basically, your password could have been compromised, but the attack would have left no traces. So there's no telling which website got compromised and whether your password or other type of information was actually compromised or not. So the recommendation was to change the password of everything. Yep.
I was under the impression that this vulnerability existed for a long time.
Yeah, it existed for about 2 years. The question was, whether people actually knew about it or not. But it was disclosed about 2 weeks ago, right before break. Two independent researchers basically published the results at about the same time. So that's when all the websites, like 500,000 websites, started to realize, oh no, we need to update the software. But yes, the exposure has been around for a long time, and but because the attack leaves no traces whatsoever, so there's no telling whether people have been using this exploit or not. Right. So what do you guys want to do first? The homework assignment, or do you want to talk about the exam question number 4? Homework. Okay, so we'll do homework first, and then the exam question. Right. Just double checking the recording is on, and then we'll start with the homework assignment. Alright, so we are now in topic 7. We're talking about subroutines, and the homework assignment is called sub 1, for the lack of creativity. And we'll take a look at the file. So here is the program itself, and it's not a mistake. Line 12 and line 13 are intentional. There are 2 invocations of the subroutine, and you should see that the second one is pretty easy to deal with. But we'll go ahead and take a look at this one first. Because I'm not using the persistent drive, I have to reset all the options for autocorrect. So I have to turn off all the options here. Use replacement table, and I might not use I today, so let's see whether this will work or not. New window for the trace. Was there any particular difficulty with this homework assignment? Go ahead.
Yeah, when you go on line 4, I guess I missed the part, because I was looking at the example on YouTube, and you don't have a line 5, it just kind of goes to line 6. So when you go to line 4, it invokes sub 1, you return until it's not true, right? Or you do return line to 5, but
okay, the way you treat line 4 is no different from the way you treat line 12 or line 13. When you invoke a subroutine, it goes through exactly the same process.
And then when you get to, I guess after the second time you get to line 4, you go back again?
Every time you invoke a subroutine, you perform exactly the same 2 steps, except the return line number would be different depending on where you are at that point. That's the only part that is different depending on where you are doing the invocation. Yep, go ahead.
The confusion I have is that when you finish line 4, the sub 1, then return line would be 5, but that's in the middle of the then statement. So
And that's okay. If that's what the return line number is telling you to go back to, that's where you go back to. Because you are the one who left that little note to yourself and say that when I'm done with this subroutine invocation, this is where I should continue the execution of the program. So you should just blindly follow that because it is a note that you left to yourself a little bit earlier. Yep, go ahead.
I think some of the examples we had, like we had one that had 2 invokes at the bottom, but then that one didn't have, like he said, 2 parts of the then. And then we had one with 2 parts of the then, but it didn't have 2 invokes on the bottom, so it was kind of like trying to infuse both into one to try to like figure out how to do it.
Okay.
So I guess I really don't have any questions until you do it. And
Okay.
if I get it wrong, then
Okay.
I got some questions.
So from the questions that I'm getting at this point, I think it is important to emphasize the way we do the invocation and the way we treat and define sub does not really matter where you are at that point. The mechanism is identical whether we're doing the invocation on line 4 or whether we're doing the invocations on line 12 and line 13. It is exactly the same mechanism. When we perform and define sub on line 9, it also does not depend on where you're going back to. Because if your return line number tells you to go to line blah blah blah, you continue execution on line blah blah blah. So the most important part is when you do the invocation, you have to leave the correct information in the return line number column, so later on you know exactly where to continue execution. So let's go ahead and trace this, just so that we can see what it looks like, and also how the variables n and x are going to get changed when we execute this particular algorithm. The precondition is we do not need to make any assumptions in n or x because they are going to be modified inside the program itself. And then we start, go ahead.
Oh, sorry, the question marks have to be there.
The question marks have to be there because I need to know, are we making any assumptions of the initial values of the variables. So that's why it is significant. It's not because I'm picky, it's because I need to know that that local variables start with unknown values to begin with, because that is an important concept when you get to cisp360, because not knowing that variables in general start with unknown values can bite you, big time, when you move on to that class.
I mean, leaving it blank is not the same.
A blank means, you're not telling me what it is. A question mark is you telling me that it is unknown. So we kind of went over this, in class already, so you got to kind of do it by the convention. And for those people who think that I'm really picky, you may be right, but I'm not nearly as picky as the C compiler. When you move on to the cisp360, you will find out that, so I thought Tech was picky, but now GCC is even more picky, and you can complain to GCC all day long, and it does not care. So let's go ahead and move on with this one. I just want to emphasize that most tools related to computers are extremely picky about little things, little details. So you got to have the habit of knowing when to specify what. Okay, so we start execution on line 10 because line 10 is the first line that is outside of the definition of a subroutine. In this case, x gets a value of 4, and on line 11, n gets a value of 3, and then we proceed on to line 12. So this is the first time we do an invocation after the spring break. So I'm going to do it a few times and basically say exactly the same thing every single time. But it's really not just me talking about exactly the same thing every time. If you have any questions about what a invocation is actually doing, you have to ask the question at this point, because otherwise the rest of the semester, the other 3 weeks or so, is going to be quite painful, because it's all going to be subroutines, and there'll be other concepts stacked on top of the return line number.
Okay.
Yep.
It doesn't matter n or x or either line.
Oh, you mean the columns? Yeah, you can flip the columns, that's fine. Yep. On line 12, we have an invocation of sub 1. There are 2 steps to invoke a subroutine. The first step is to remember where am I supposed to come back to when the subroutine is done. So you have to allocate the leftmost available column so that we use that column and label it first as return line number, and then we use it to remember where am I supposed to go back to when the subroutine is done. The reason why we need to remember is when you continue execution in sub 1, at some point you will get to line 9. The question is, at line 9, where am I supposed to go to continue execution? That's why you have to remember that now when you are just invoking the subroutine. In this case, because the invocation is on line 12, the logical line that is following line 12 is line 13. So we write down line 13 here just so that we know when the subroutine is done, we have to continue execution on line 13. The second step to invoke the subroutine is to continue execution in the subroutine from the beginning of the entire subroutine. In this case, the subroutine starts on line 2, so we'll continue execution on line 2. Line 2 is the beginning of a conditional statement, so we'll do what the conditional statement is supposed to do, evaluate the condition first. N is greater than 0 is true because N at this point has a value of 3. So we move into the then branch starting on line 3. Line 3 says we want to subtract 1 from N. N goes from 3 to 2, and then we move on to line 4. Line 4 is an invoke statement, and as I said a little bit earlier in today's lecture, we'll do exactly the same 2 steps as we were executing line 12, which means 1, we allocate the leftmost available column, label it as return line number, write down what line is supposed to be following this invoke statement, and then we continue execution from the beginning of the sub 1 subroutine. Yes, go ahead.
I was a little confused because from row 6, I went to 4 because I was watching some videos and it looks like, well, is it a possibility that we look at one of your videos when we're done with this just to show you kind of what I was looking at?
Well, if you know approximately where in the video, that would be fine. But
Okay.
if you, I cannot scan through the video during class because that's just going to be taking up a little bit too much time.
Okay.
Yep.
I had a quick question. On row 5, you put for the line 12. Why wouldn't we just go to line 13 and then for the red line it'd be post?
Say it again, please.
For row 5.
On row 5.
Yeah, it's 12 with red line and 13.
Yes.
How come we wouldn't just do 13 with red line and post?
Because we are executing line 12.
It's because you're not there yet, right?
We're not. Yeah, exactly. Because after line 11, which is a simple assignment statement, we move on to line 12. And line 12 is supposed to invoke the subroutine sub 1. And when sub 1 is done, when this invocation of sub 1 is done, we continue execution on line 13. And then line 13 has its own stuff to do, but I don't really care what line 13 has to do at this point because I'm not even done with line 12 yet. Okay? All right, so now we're on line 4, but getting back to the other comment a little bit earlier, when we continue when you invoke a subroutine, you always continue execution at the beginning of a subroutine, never in the middle, always from the very beginning. Yes?
Well, part of that question was you don't just do it once, you kind of keep doing it, right?
Yes,
Okay.
but that's okay. It's still the same mechanism. So on line 12, the return line number is going to be line 5 because line 5 is the one that is following line 4. So the return line number is line 5. And once I remember where I'm supposed to go back to, I can now continue execution in the subroutine that I'm invoking. Well, there's only one subroutine in the entire program, so it is sub 1 again, and I start from the beginning of sub 1, which is line 2 again. So I will evaluate the same condition, but this time it has, well, the N is different because N is now 2, but 2 is greater than 0 is still true. Yep.
I have a question. If you, if the first line of the body of the subroutine is an assignment statement, do we just start there as well?
Yes.
Okay.
Whatever it is.
Okay.
Whatever it is, you start there. Okay. So we are now on line 3 because the condition of the conditional statement is true. On line 3, N gets decremented to a value of 1. We move on to line 4, and we are doing exactly the same thing again. allocate the leftmost available column, label it return line number, and then write down which line I'm supposed to come back to when the subroutine is done, which is usually the line right after the invocation, but occasionally it is not, depending on logically which line is actually following it. And then we continue execution in the subroutine that we're invoking, starting on line 2 in this case, because line 2 is the beginning of this subroutine. Evaluate the condition, because at this point it's just a conditional statement. N is 1, 1 is greater than 0 is still true. We move on to line 3, subtract 1 from n goes from 1 to 0. Go to line 4, and then we have one last invocation. Allocate the leftmost available column, write down which line we're supposed to go back to, and then continue execution in the subroutine. And this is the 4th time I say pretty much the same thing. But that's the whole point, okay? For those of you who realize that I have been saying exactly the same thing like 4 times all over, that's the whole point. The mechanism of invoking a subroutine does not change. Okay, it is always the same way regardless of where the invocation is. Yes?
What I think what threw me off is that there's a line 5, and on the left hand side, for example, on the algorithm,
Yes.
there's a 5 after the invoke, and in the example we got in the class, it goes directly to end if.
But remember what I said, it is the line that is logically following the invoke statement.
Yeah.
So in the other example, the line that is logically following the invoke statement, it's outside of the conditional statement. So that's why I wrote down that line. In this case, the line that is logically following the invoke statement is line 5. It is sequential to the invoke statement.
I kind of get it now. I mean, I'm caught up to you right now.
Okay.
It's just that's what threw me off when I was reviewing it.
But there were some other examples where it was just the line following it too. So you got to kind of draw your own conclusion based on what we have talked about. Okay, so now we are on line 2 again, and line 2 is evaluating the same condition, but this time with a different result, because n is 0 at this point. Let me just split the screen so we can see n at this point. Okay, so n has a value of 0 at this point, and as a result, the condition is false. We do not get into line 3 anymore. We get to line 7, which is the else part of the conditional statement. Line 7 doesn't do much. All it does is to change x to a value of 2, and then we get out of the conditional statement. We end up on line 9, which is the end of the subroutine. The end of a subroutine has 2 things to do as well. The first thing it has to do is to look up the rightmost active return line number that is not deallocated. At this point, it's column H. Column H is telling me to continue execution on line 5. So I make a note of line 5 here first, and then I have no use of column H anymore, and as a result, I deallocate it over here, and I use the notation of cross out or strike through to indicate this is now deallocated, which means it cannot be active anymore. That concludes what line 9 is supposed to do, and then we move on and continue our execution on line 5. Are there any questions at this point? That's okay, because there'll be like 3 more times I'll do exactly the same thing, so you can ask questions in those 3 other times that we'll do the return. Now we're back onto line 5. And yes, absolutely, we are now in the middle of a subroutine, but that's the whole point of a return from inside a subroutine is we just go to the return line number and use that to tell us where to go in order to continue execution. Now that we are continuing execution on line 5, we just do whatever line 5 is telling us to do. X gets a value, X gets X plus 1. Okay, it was 2 before, now it is 3. After line 3, we get out of the conditional statement because it is the last line of the then branch of a conditional statement. So we now continue execution on line 9. Line 9, once again, has 2 things to do. Look up the rightmost active return line number. It is not column H anymore because you can see the column H is now deallocated. So the rightmost active return line number is actually column G, which tells me to continue execution on line 5. I make a note here to continue execution on line 5, and then I indicate that this column is no longer in use because I have to deallocate it. Now I'm on line 5 again. Line 5 is just adding 1 to X. X was 3, now it is 4. Then we continue execution on line 9 again. And it will do exactly the same thing. Look up the rightmost active return line number. If I draw this bar just a little bit lower, I should be able to see this part here. So the rightmost active return line number is column F. It is telling me to continue execution on line 5. So I'll make a note of that, and then I'll deallocate that column. Now I continue execution on line 5, which is just adding 1 to x. X gets 4. X was 4 before, now it is 5. And then I get to line 9. Line 9 is going to do exactly the same thing, except there's only one return line number left of all the columns, which is column E. It tells me to continue execution on line 13. So we make a note of line 13 here, and then we indicate that column E is now deallocated. And we continue execution on line 13. Are there any questions at this point? Go ahead.
The only reason you're tracing row 9 in the algorithm is because it's ending a subroutine.
Yes. And it actually has things to do.
Okay.
Yep.
Otherwise you don't trace end if.
I don't trace end if, end while. I don't trace repeat. I don't trace else, because those lines actually do not have anything particular to do. But in this case it does, because the end of a subroutine is very important. I have to figure out where I'm supposed to go in order to continue execution. Yeah. So now that we are on line 13, we'll do pretty much the same thing, again. But for people who actually just copy and pasted everything, that would be the wrong answer. This time would be a lot easier, because on line 13, I have to invoke sub1 again. 2 steps. Allocate the leftmost available column. Which one is my leftmost available column at this point? Column E is the leftmost available, because I just deallocated everything all the way down to column E. So I reallocate column E, okay, for the purpose of a return line number. And this time the return line number is post, because the logical line that is following line 13 is post. There's no additional lines anymore in this program. And then I continue execution in the subroutine, starting from the very beginning of the subroutine, which is on line 2. So I get back to line 2 again, and line 2 evaluates the condition. It's a conditional statement. N is greater than 0 is false, because N is 0 at this point. If you look at the column for N, it has a value of 0 already. So that means I have to continue execution in the else branch of the conditional statement, which is on line 7. Line 7 is just going to reassign 2 to x. So x is changed to 2 again this time. And then we get out of the conditional statement. We get to line 9. Line 9 will do its usual thing, which is to look up the rightmost active return line number, which is column E at this point. I make a note that I have to continue execution at post, and then we have no use of column E anymore. So I indicate that it is now deallocated. I continue execution at post. I'm all done. So that is the full trace of this particular algorithm. Are there any questions? Yep.
I know where the video is.
Okay.
It's from April 10th, this class obviously, and it's an hour and 4 minutes in.
1 hour and 4 minutes? Okay.
I could have watched it, but I just kept it paused and I didn't.
Okay, that's fine. Alright, so we look up the videos tab. Because if I did say something wrong, I have to correct it then also.
Well, I don't know if it's wrong, if I just read it the wrong way.
Okay, go ahead.
For line 32, when you crossed out the last return line, I initially did that, but then I saw one of your earlier videos that for the return line post, you didn't cross out the last return line, so then I just took it off. So I don't have the last for the return line post. I didn't cross it out.
You have to cross it out. If I did not do it before, it's probably because I forgot to do it. In my notes, I think I always cross out the last return line number. In other words, okay, let's get to this one first. What time again?
The hour and 4 minutes?
1 hour and 14.
4.
4 and out 4. Okay.
In 2 seconds.
Oh, thank you. Getting there, getting there.
That's good. You see how you went from like return line to return line to return line? You went from 13 to 9. That's kind of what I did in the last one. I went from 12 to 4. You see
Okay.
what I'm saying?
Okay,
So-
wait, but hold on a second here. In this case, we have 2 subroutines.
Enlarge it.
We have 2 subroutines here.
What? But how are you supposed to know how many subroutines you have? I just thought.
So it says define sub 1 and then line 4 define sub 2.
So you have 3
define sub
subroutines,
3. Yeah, there's 3.
right? Or 2?
See it?
You have 3, not 2.
Oh yeah, we have multiple subroutines here. So on line 13, which is here, I continue execution at the beginning of sub 3, which is on line 9. So that explains your row 4 and 5. On line 9, I invoke sub 2, so I continue execution on the first line of sub 2, which is line 5. So that explains how I continue execution over here from line 9. Once I get to line 5 invokes sub 1, so I continue execution on line 2, so this will be 2 here.
Okay,
So
so
if-
I have to pay attention to the numbers, basically. Like, cause like when it says sub 1 and stuff like that.
Correct.
Okay.
Yeah, because we always begin, when you invoke a subroutine, we always start from the beginning of the subroutine that you're invoking. Whether you're already in that subroutine or not is irrelevant. That part does not matter. So if I kind of fast forward a little bit here, I should see, 2, got too far. See, that's 2 right there. So you have to understand where we are in order to get to which other point.
Okay, well, I guess then my last question is, how come you can have like invoke sub 1 1,000 different times in one subroutine? You know what I mean? Well, not 1,000, but like 3.
Okay,
You know what I mean?
but why not?
I don't know.
There's no restriction. There's no such thing. There's no restriction. We always do the same thing when we invoke. We always do the same thing when we get to the end of a subroutine. There's no restrictions. There are no any other restrictions when you invoke a subroutine or when you're at the end of a subroutine to continue to determine where to go to continue execution.
Okay, my last question, I swear. So on row 8,
Uh-huh.
right, you're at 5.
Yeah.
And so you invoke when you return at 6, but you went back up to 2 because you said, what again?
Because we're on line 5, we're invoking sub 1. The
Right.
definition of subroutine sub 1, or the inside the actual code of sub 1 starts on line 2.
Okay, so that's why when we go to 4, we return to 5 and then go back up to 2 in our homework.
That is correct.
Okay.
Yep.
So it's kind of like, it's like another way of saying, it's like a loop, right? I mean, the invoke could be, it's a way of saying go back to the beginning.
It is not a loop. An invoke statement is an invoke statement. It does those 2 things, all the time. Okay? It only does the 2 things that we talk about at this point. When you invoke a subroutine, okay, let's spell it out again. Okay? But this is going to be the last time I spell it out. We allocate the leftmost available column, label it return line number, write down what line is logically following the invoke statement, and then we continue execution in the subroutine that we're invoking from the very beginning of that subroutine. Those are the steps that you have to perform in the invoke statement, regardless of where the invoke statement is, and also regardless of how many times that subroutine has been invoked already at this point. It does not matter at all. Okay.
And then the thing you said you do not trace was the and while else, like when you do the
And while, else, and if, repeat, those we do not trace because they don't actually do anything. But and define sub does do something very important because we have to find out where we're supposed to go back to and then actually deallocate a column, and that's why we cannot not trace it.
And you also don't, you You also do not trace the defined subroutine.
Say that again?
You also do not trace the defined subroutine.
That is correct, because the define sub blah 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 is only there to mark the beginning, but it doesn't really do anything other than labeling this is the beginning of a subroutine. Okay, all right. Yep.
If we use the X's instead of the strike through, are we still good?
X's would be fine, because that's how the older convention, that's how I indicate it's deallocated. The reason why I switched to the strikeout is because if I use a strikeout, it is more clear what I'm deallocating. If I just exit out, it just says, okay, these columns are now deallocated, but what were they used for before? That was not clear. But when I use a strike through, it is more clear that they were used for, okay, this one was used for return line number, and I'm deallocating it. So it's really for clarity purposes, but using the X's, it's still an indication that those columns are not useful anymore. So it's fine too.
In regards to an array, and we have a disjunction to question at the end, so like the OR statement, so it's like B is greater than E, or A sub I equals K. You said if one of them's true, don't continue to write the other, or you'll mark us off. But
Or to be more specific, when the left-hand side is true,
Correct.
you do not evaluate the right-hand side.
But in all of our examples, you evaluated both before putting true. But I mean, the left side would be true, and you would
If
still
the
put
left-hand
OR.
side is false, then you have to evaluate the right-hand side as well.
No, I understand, but I'm saying in our examples, even if the left side was true, you still put the OR, B is greater than E, and then put true after that. I'm just saying, are we going to get marked down if we put the OR? And
In
when
the
left-
exam, it'll be very clear that we have to observe short circuit evaluation.
Okay.
So as a result, you have to stop as soon as you can.
Okay.
Yep.
For the practice exam questions, are the answers only on the YouTube videos, or did you post them on Moodle?
I think it is only on YouTube. Yep. And question number 4, I have not done it yet, so I'm going to do it right now. But before we go any further,
Well, for the YouTube ones though, I mean, we went through the traces, but we didn't really go over fully how to actually answer all of the questions. Does that make sense? Because, like, I have the traces that we did in class, but as far as what you're looking for in those answers, because it's a
You mean
little
like
bit
the
different than how
rubric?
we've normally taken the test.
right.
I don't think we necessarily went over all of what those answers would be.
Okay, let's take a look. Well, let's take a look at question number 4 first, because
Sure.
we do want to go over the question first before we go any further. So I think it is practice exam of exam 2. Yep, that's the one. Okay, so here's question number 4. Let me just kind of zoom in. I like the style sheet, that I'm using right now, because if I zoom in enough, the other stuff just kind of disappears. So it actually makes it easier to read. So let's go over this one first, because I don't think we traced this one yet. So that's the first thing we'll do, is to trace it. But the grading criteria is going to be exactly like this. You have to tell me what is the condition of line 2, and then you tell me, what is the result of, what are the values inside the elements on line 12,
So
and then
like-
every time, yeah, go ahead.
Sorry, so like where it says line 2, the condition is, are you looking for true, false? Because
Yes.
that's, okay.
Yep, the condition is true or the condition is false. So each time the algorithm reaches line 2, indicate the condition on line 2. Each
So-
time yeah, go
Sorry,
ahead.
so for the first one, you want the first time it executed line 2, and then the next time it executes
Correct.
line 2.
Yep,
each
so
time
it'll be
after.
in that sequence. Yep.
Okay.
And the same thing applies to line 12. Every time we get to line 12, indicate the values of all elements in array A. So you basically just fill in the underlined portion and say, okay, at this point, A bracket 0 has a value of blah, A bracket 1 has a value of blah, and so on. Okay. And that's how I would grade it, is just, observe, what you write down here. And obviously, some people might make a mistake at some point, but, assuming the mistake is not, made early on, it will still get partial credit. Alright, so the first thing we'll do is to trace it. So I'm gonna use a new sheet to write down the algorithm. Yes?
Where is this, like in the zip file? Is this
No,
the-
it is on Moodle. exactly what I clicked earlier today.
I missed
Well, let me write this down first, okay? Yeah, let's just give me a chance to do this first. This is also what we did before the break. Oh, okay. I forgot to turn off one of the autocorrect thing. Placement table, yep. Forgot to turn off the I. Let's see. This one. I is 0, while I is less than or equal to. Alright, so we got everything. Indentation. A little more. I think this mouse is not as precise as what it should be. I have to ask the department to buy me a 8,000 DPI gaming mouse.
Remember I said to have GeForce, whatever the crap is.
Yep. On my own computers, I have I don't have a mouse or a touchpad. I use the touch point on an IBM Lenovo computer. It looks like an eraser. It's right between the G, H, and the B keys on the keyboard.
Oh, that.
Yeah, it's pressure sensitive. It doesn't even move. You know, it's just pressure sensitive. When you push that thing, the cursor will just move in a certain direction. And that's all I use.
Those are real old. I think they were popular when it was like years ago.
I still like it a lot.
Yeah, me too.
Yep. All right, so let's go ahead and trace this one. This one will take a little bit longer, and also, it will take up more columns. So I might need to resize the screen a little bit, just to fit everything on the screen. We have comments because we do have conditions to evaluate on line 2 as well as on line 10. Here we have line number. We have several variables here. We got I, we got T, and then we got array A. And I think I have to give you a particular initial value. So we have 3, 5, and 4 as initial values. So we got 3, 5, 4. And, okay. 3 goes here, 5 goes here, 4 goes here. Because I have to indicate which one is which element here. So this array has 3 elements. It has a size of 3. T as a variable has an unknown value to begin with. I also has an unknown value to begin with. That becomes my precondition. So let me just fit everything in first, like that. All right. So now we continue execution. We start execution on the first line that is not inside any subroutine definition. From line 1 to line 8 is the definition of. Excuse me. Line 1 to 7 is the definition of ABC. Line 8 to line 14 is the definition of DEF. So the first line and the only line that is outside of the definition of a subroutine is line 15. And line 15 says, we want to invoke DEF, so we do the same thing at this point. We allocate the leftmost available column, label it return line number, and then we indicate where we're supposed to go when we come back from subroutine DEF. In this case, it is post because there's no line following line 15, so we have to use post as the return line number. And then we continue execution in the subroutine that we're invoking, starting on the first line, which in this case is line 9. Question? Yep.
So,
Okay, go ahead.
So it's okay to start from invoke?
With,
Is it start your trace from the invoke statement?
on the invoke on line 15, yes.
Because it's outside the.
Because it's the first line that is outside of the definition of the subroutine. Okay, so we are now on line 9. Line 9 doesn't do anything too exciting. I gets a value of 0. On line 10, we have to evaluate the condition. I is less than bar A bar minus 1. Bar A bar in this case is 3. 3 minus 1 is 2. I has a value of 0. 0 is less than 2 is true. We go into the body of the loop on line 11. We invoke ABC. When we invoke a subroutine, we allocate the leftmost available column, label it return line number, write down the line number that we're supposed to come back to, which is the line that is logically following the invoke statement. The line that is logically following line 11 is line 12. So we write down line 12 here, and then we continue execution in the subroutine that we're invoking. Line 12, ABC starts on line 2, so we continue execution on line 2 in this case. Line 2 starts with the condition of A bracket I is greater than A bracket I plus 1. Okay, is that true or is that false? Okay, well, what is I? I at this point has a value of 2, so A bracket I refers to A bracket 0, which has a value of 3. A bracket I plus 1, close bracket, is referring to A bracket 1, because I plus 1 is 1. And that has a value of 5. 3 is greater than 5 is false. Are we doing okay so far with this step here? Okay. Now, because the condition is false, and this is a conditional statement, but there's nothing to do, there's no else branch here, which means, hey, you know, if the condition is false, there's nothing to do. So we skip all the way around the entire conditional statement, and we end up on line 7, and define sub. The end-defined sub is going to do exactly the same two things that we have been talking about in this class, which is to look up the rightmost active return line number column, which is column I. It tells us to continue execution on line 12. Let's make a note of that. And then we have no use of column I anymore, so I'm just going to deallocate it. Like so. And then we continue execution on line 12. Line 12 is just adding 1 to I. Okay, column C is incremented from 0 to 1. And then we go back to the beginning of the loop, which is on line 10. Line 10 is re-evaluating I is less than bar A bar minus 1. I is now 1, bar A bar minus 1 is 2, 1 is less than 2 is true.
Can you repeat the logic behind on row 10 why it's false?
Why it is false? I mean row 10?
Yeah.
Because at this point, I has a value of 0. So A bracket I refers to A bracket 0, which has a value of 3. A bracket I plus 1, you have to evaluate I plus 1 first. 0 plus 1 is 1. So A bracket open bracket I plus 1 close bracket refers to A bracket 1, which has a value of 5. 3 is greater than 5 is false. Now we are back on line 10. It is true, so we have to continue execution in the body of the loop, which is on line 11. We invoke ABC again, which means we have to reallocate the leftmost available column. In this case, is column I. And remember where we're supposed to go back to, which is on line 12. And then we continue execution in the subroutine that we're invoking. In this case, it's on line 2, because line 2 is the first line of the subroutine ABC. And it's checking whether A bracket I is greater than A bracket I plus 1. A bracket I is now A bracket 1 because I has a value of 1. It has a value of 5. A bracket I plus 1 is referring to A bracket 2 because I is 1, 1 plus 1 is 2. And it has a value of 4. 5 is greater than 4 is true. So this time we do have something to do. T gets A bracket I on line 3. So T is the one that is updated with the value of A bracket 1, which is 5, has a value of 5. We go to line 4. Line 4 is copying the value of A bracket 2 to A bracket 1. So A bracket 1 gets the value of 4. And let me split the screen so we can see at least the header of the rows. Here we go. All right. And then on line 5, we want to copy the value of t to a bracket I plus 1. I has a value of 1 at this point, so a bracket I plus 1 is referring to a bracket 2. A bracket 2 is column G, it gets the value of t, and t has a value of 5. So that's how we'll copy the values. After line 5, we are at the end of the then branch, so we get out of the conditional statement to continue on to line 7. Line 7 has the usual thing to do, and I'm hoping by now it is boring to talk about what we do at the end of a subroutine, because we have been talking about this. This is at least the 10th time that we have encountered end-defined sub. But that's really the whole point. It doesn't matter where you are. When you get to end-defined sub, you perform those steps that we have been talking about all along. Okay? So on line 7, we are at the end of the subroutine. We locate the rightmost active return line number, which is column I. It tells us to continue execution on line 12. We make a note of that, and then we have no use of column I anymore. We deallocate it by using the strike out font effect. So we just strike it out. And now we continue execution on line 12. Line 12 is adding 1 to I. I had a value of 1, now it has a value of 2. We go back to the beginning of the loop, which is on line 10. I is 2, bar A bar minus 1 is 2 as well. 2 is less than 2 is false. So we get out of the loop, we end up on line 14. Line 14 is end-defined sub. We have to look up the rightmost active return line number. Column I is no longer the rightmost because it is now deallocated. Column H is the rightmost. It tells us to continue execution at post. So we'll make a note of that. And then we have no use of column H at this point, so we deallocate it. We now continue execution at post, which means we're at the end of the entire trace. We're all done. All right. So to answer the question, let's map this trace to what I'm looking for grading purposes. So to map this, let me get rid. Well, I guess I still want it to be like that. The first time we get to line 2 is over here on row 10 of the trace. So the answer is this condition is going to be false. And then the first time we get to line 12 is over here. So you have to indicate at the end of this thing here, basically the values of the 3 elements have not changed. They are still 3, 5, and 4. So write 3 here, 5 here, and 4 over here. The second time we get to line 2 is down here. This is the second time we get to line 2. The condition is true. So you want to write down true at this point, okay, for this underbar here. And then the next time we get to line 12 is over here. So by the time we get to line 12 over here, the values of the 3 elements in A should be 3, 4, and 5. So you have to write down 3, 4, and 5 down here. And I had a typo here. I use a curly brace instead of a square bracket. But that's what I'm looking for when I look for the answers.
We don't have to fill in those remaining blanks, like with the redundancy or anything.
Nope, you just leave them blank, and not do anything. If you want to put down like NA, that's fine, not applicable. But you can just leave them blank if you want to. Because I said, note that the amount of space available does not necessarily indicate what is actually needed. I just give you some extra space. And no one in this class should be thrown off by those extra space anymore, because I said, well, I might give you more space than you actually need. Yep. Attendance, very good. We're pretty close to the end of the semester, so I think we'll have like 2 more sheets and we are all done. This is the first time I actually keep track of the entire pile of my row sheets. At the end of the semester, what I will also do is to kind of check, the frequency of absences as opposed to, performance in class and see if there's any correlation. Sometimes there may be no correlation whatsoever. People who miss like just, at, the borderline of getting dropped may still get an A in the class, and some people who attended every single class may not be, getting a very good grade either. But I want to see if there's any correlation. That's what I'm going to do at the end of the semester. Yep.
Has the grade book been cleaned up so we can see our final copy of the grade?
Not yet, I don't think. You might want to check it first, because sometimes I've done things and I don't remember doing it. It's like driving home. It's like, how do I get here? And I drive a stick shift too. You have to actually think about shifting, and I can have no recollection of how I get home. By the time I get home, it's like, oh, I'm on the driveway now.
It's called highway hypnosis. That's what it is.
But I drive local. It's not even on the highway. I only drive locally.
That's just the term for it.
Right.
Oh, and then on practice exam question one, or not question one, it was one of the ones where we had to do that 9.5, 10.5 thing. Are you going to clear that up as to how you're going to ask that specifically?
Yeah. I'm going to clean that up and clearly indicate, this is the line where you have to indicate the value of blah, blah, blah. So on that line, there will be the instruction to say, okay, write down the value of.
Yeah, like after line 9, before line 10, though.
Yeah.
Just want to make sure.
Yeah. All right. Any other questions?
So when is the exam?
When?
Thursday.
Thursday.
This Thursday.
Yep. It's still open book, open notes. Okay, the whole point of my exams is not having you guys to memorize anything. Okay, if you study and you have been keeping up with this class, I would say the details is not going to be a major concern. Okay, in other words, there's very little for you to memorize if you understand the material. The test is all about the application. In other words, you will see combinations that you may not have seen before, and that's actually intentional. Okay, you have block A, you have block B, and then I explain how block A works, I explain how block B works, and you may see the first time I connect a block B, after block A, but it doesn't change what block A does. It doesn't change what block B does. It just changes how the combination works. Okay, so you have to kind of apply that type of reasoning when you are answering questions in the test.
Wait, what about block A and block B?
I was just using that as an example to basically make that point of my exams typically ask you guys to apply what you have learned instead of regurgitate or just repeat a procedure of doing something that we have done over and over again. In many ways, it is doing the same thing over and over again. It's just oh, we have not seen an invoke statement from here. Doesn't change how we do the invoke statement. All right, so are there any other questions before we move on to local variables? Yes?
How many questions will be on the exam?
It'll be about, I would say about 4 or 5 questions.
And we'll have enough time to trace each of them if you want to?
I would say so, yeah.
On the exam, when we do the indentation part, for example, how do we show you we're doing indentation?
Most people just use the spacing, and some people use a tab character to clearly indicate this is like one indentation, this is another indentation. So this way, even when some handwriting is kind of shifting all over the place, I can just count 1, 2, and 3. I will not give you any type of indentation questions this time because it's just difficult to grade. Yeah, it's very difficult to grade, because the penmanship of some submission was kind of difficult to read to begin with. So I'm just going to give you the code correctly indented to begin with, so that you guys can just kind of follow that.
But that would be the best way to show that, right?
Because it is very clear to me, how many levels of indentation is already there. There was a question.
Are you being tested about the local variables?
No, local variables will not be a part of the test. In other words, everything only up to invoking and returning from a subroutine, but not local variables.
And then we have to bring our own paper, right?
If you think you will need extra paper for tracing, yes, you definitely want to bring your own. And I'll bring my bag of calculators too, just in case someone needs to do, borrow a calculator. I don't think it's going to be a big issue, because it will just be adding something or multiply by 2 or something like that. Yep.
Is it going to involve logical operators like or and?
Yes. It's really hard for this class not to be somewhat comprehensive. The only thing I can do is to exclude like pre and post conditions. Okay, there won't be any application of the forget rule or the substitution rule and stuff like that. But as far as the operators are concerned, the mod operator will be in it. The bar A bar operator will be in it. Conjunction, disjunction will be in it. All the control structure, like if statements, while statements, repeat statements, will be in there. Any other questions? Okay, if there are no questions, what we'll do is we'll move on, and let me just show you guys where we are at this point, just so that when you are reading the notes, you know where to find the notes. We are now in topic 7, and in topic 7, okay, the first thing is this is the link to the questions. Okay, it's called practice question of exam 2. I believe it is not hidden from your view. I mean, the gray stuff here is hidden from your view, but the stuff that is not grayed out is not hidden from your view, so you should see this one as well. And then we have a few practice questions, but I would not use those, because I'm changing the way I'm, asking questions. And we are now, this is the note that I want you guys to read, is updated subroutine notes. Right there. Okay, so in subroutine, in the updated subroutine notes, this is the entire thing about subroutines. We are now done with section 3. We are now moving on to section 4. Okay, so this is what you want to read. Actually, for the most part, if you just copy this URL, you can copy and paste it without having to get into Moodle in order to get to the website. You don't try to copy it right now because it's getting recorded, so you can just kind of freeze the frame, when you have time to watch the YouTube, or you just log into Moodle, and that's the easiest way to do it. So we still have variables to talk about by value parameters, by reference parameters, and also returning values before we are done with subroutines. So these are all related to subroutines, and that's why we really kind of make sure that we have all the concepts cleared up already at this point for section 3. Because we are now moving on to section 4, which talks about local variables. Okay, so when we talk about local variables, the first thing we'll do is to do a really simple and quick example to illustrate what happens when we do not have local variables and why we have a problem with that approach. Okay, so we'll go ahead and write a very simple thing here. Define sub. I'll just call this loop 1. Okay, so loop 1 is going to say I get 0 while I is less than. Let's make it a fairly short loop here. That's 2. Let's say 2. We'll say I gets I plus 1, and x gets x plus 1 too. And while, and define sub. So just by looking at this subroutine, what do you think the subroutine does to x?
Increments its value by 2.
Exactly. Okay, so all it does is to increment the value of x by 2. Okay, so what we'll do is we'll define another subroutine. We'll call this loop 2. Okay, the subroutine is called loop 2, and in this one I have about the same kind of structure. While I is less than 2, do. Except instead of directly changing the value of x, I'm going to say invoke loop 1, and I will say I gets I plus 1 afterwards, and while, and define sub. Okay, let's fix the indentation first so it's easier to read. And outside of the entire program, I will have to initialize the value of x. Let's say it starts with the value of 0, and now invoke loop 2. So according to this code here, what do you think loop 2 should do? Just look at loop 2 all by itself and tell me what loop 2 is supposed to do, which is from line 8 to line 14. If you don't look at loop 1, what do you think loop 2 does? It's going to invoke loop 1 twice, right? Because I initialize I to 0, so the first time I has a value of 0, 0 is less than 2, invoke loop 1, I gets I plus 1, it becomes 1. The second time, I is 1, I invoke loop 1 again, I gets I plus 1, it makes it 2, and then the third time I get to line 10, I have to get out, because I would have a value of 2, and 2 is not less than 2, we get out. But every time I invoke loop 1, according to what we understood about loop 1, is it will increment the value of x by 2. Okay, so if loop 1, each invocation of loop 1 is incrementing the value of x by 2, and I'm invoking it twice, that means the entire program should increment the value of x by 4. Because I'm doing it twice. I'm incrementing it by 2 twice. So that's the reason why it should increment the value of x by 4. But that's not what it does. Okay? The reason why it's not going to do this has to do with there's only one variable I. Okay. So let's take a look and see why this program is not going to work the way that I said it would, because it seems kind of apparent that it should do that, but it's not going to do that. We need comments because we have two conditions. We have a condition on line 3, and we have another condition on line 10. Here's our line number. We have I, and then we have x as our variables. So they start with unknown values as our precondition. All right. The first line outside of the definition of a subroutine is line 15, and x gets a value of 0. And then on line 16, we invoke loop 2. Okay. We allocate the leftmost column for return line number, and the return line number is post because line 16 is the last line of the entire program. We continue execution on the first line of the subroutine that we're invoking, which is line 9. Line 9 is initializing I to 0. So far, nothing really too mysterious. Okay. On line 10, we are at the beginning of a loop here. We evaluate the condition I is less than 2 is true because I has a value of 0 at this point. On line 11, we invoke the other subroutine loop 1, which is doing pretty much the same thing as what we have been talking about this for this lecture. We allocate the leftmost available column, label it return line number. Remember where we're supposed to go back to. The invoke statement is on line 11, and line 12 is the line that is logically following line 11. So we have to write down line 12 as the line that we have to go back to. And then we continue execution on the first line of the subroutine that we're invoking. When invoking loop 1, the definition of loop 1 is over here. The first line is line 2. Line 2 starts with a condition 2. I is less than 2 is also true. We get to line 3. Oops. I take it back. Line 2 is initializing I to 0 again. Okay? And then line 3 is the one that is checking. Excuse me for this mistake here. But I is 0. 0 is less than 2 is true. So we get into the loop on line 4. I gets I plus 1, so I is now 1. On line 5, x gets x plus 1, so x is 1 as well. And then we go back to the beginning of the loop on line 3. I is less than 2 is still true because I has a value of 1. We get to line 4, I gets incremented to 2. On line 5, x gets incremented to 2 as well. And then we get back to line 3. I is less than 2 is false because I has a value of 2 at this point. And then we get out of the loop, we get to line 7. Line 7 is n-defined sub. We have to look up the rightmost active return line number, which is column F. Column F tells us to continue execution on line 12. Let's make a note of that. And then we have no use of column F. Let's deallocate it. And now we continue execution on line 12. Line 12 is just adding 1 to I. I is now incremented from 2 to 3. We get back to the beginning of the loop, which is on line 10. Line 10 reevaluates I is less than 2. It is false. Right? So since it is false, we get out of the loop. We get to line 14. Line 14 is the end of a subroutine. We have to look up the rightmost return line number, which is column E. It tells us to continue execution at post. We have no use of column E anymore. We indicate it is deallocated. we continue execution at post, we're all done. So in the end, x is only incremented by 2, not by 4, as we kind of expected earlier on. What is the reason? The reason has to do with there's only one variable I. Okay, I was trying to use the same variable in 2 different subroutines for 2 different loops. If you look at loop 2, it looks like it should work because I is initialized to 0. For each iteration, I increment it by 1, and I get out of the loop when I becomes 2. So it should go through the loop twice, but it did not. Because after it invokes loop 1 the first time, loop 1 comes back with I already changed to a value of 2. Because there's only one variable I being shared by 2 subroutines. Are we doing okay so far? So if I really want this program to go through the loop in loop 2 exactly twice, the easiest fix to that is to change the variable. Instead of variable I, we'll just call this variable j. In other words, from line 9 to line 12, every time I refer to variable I, change that to j. Now obviously we'll have one more column in the trace, but that would fix the problem. That's an easy fix. There's no need for local variables. Well, we only have 2 subroutines here. What if you have 300 subroutines? What kind of crazy program will have 300 subroutines? I'll tell you what, a small program. A small program will have about a few hundred subroutines. A larger program will have thousands, tens of thousands, or hundreds of thousands of subroutines. So when you have, let's say, 1,000 subroutines, how can you be sure that a particular variable is not already being in use in another subroutine?
Search function.
It will take you a bit of time, to double check, right? And the whole time, you were trying to write your subroutine, you have a team of 10 people, and those 10 people will have to do the same thing. And you better make sure that when you say, well, I can see that variable XYZ is not being used, someone else is not thinking exactly the same thing and start to use XYZ as you try to use XYZ as a variable. So that approach doesn't work well when you have thousands of subroutines in any type of realistic type of program. You cannot just say, well, I'm going to use another name, another variable. Is that making any sense? Okay. But I have a different approach. Let's prefix the variables with the name of a subroutine. So in this case, on line 9, everything inside loop 2, instead of just saying I would say this is loop 2 underscore I. That would fix that problem because now each name is unique to the subroutine. So everything inside loop 1 from line 2 to line 5, every time I see I would change it to loop 1 underscore I. So I would use the name of a subroutine to prefix the name of the variable. So this way, they're guaranteed to be unique. Well, if they're guaranteed to be unique only if you keep following that rule consistently. What happens when you copy and paste code? Because that piece of logic, I want to do it over here as well. What happens when you copy and paste? The name of the variables will be copied and pasted as well. So unless you remember, oh, okay, I need to change all of those prefixes for this particular subroutine, if you miss one of those, then your program is not going to work because it will be using the same variable that you were using in another subroutine, and you have interference between those variables, or between the subroutines. Is that making any sense? So we have a problem now because I want to use just a simple variable I. I don't want to have to worry about whether some other subroutine is already using that variable name or not. So the concept that we are introducing now is called a local variable. A local variable on the surface is a very simple change to the program. The only thing I need to do syntactically in this class is to insert a row here and just say local I. In other words, I is now a local variable as opposed to a global variable. So syntactically, it is not really a whole lot of change. We just have to say local I and local I here. But when you trace the algorithm, it is now entirely different. Because when we have a local variable I, it behaves very kind of strangely, but it's not something that we haven't seen before. It's local in two senses. It is local as in this local variable I is only visible when you're inside loop 2. The other local variable I is only visible when you're in loop 1. That's the first aspect of being local. But the second part of being local is each invocation of a subroutine has also its own copy of a local variable. Okay. So let's trace this. We have time to trace this one more time. So this time I'm going to trace it in sheet 7. So I should not have changed the original algorithm, but that's okay. I'm going to use sheet 7 and show you guys what to do with this one. Okay. We still got comments. We have line number, and then we have one variable x to begin with. This is the first thing that is completely different from the last time. Because what about I? Well, guess what? A local variable does not even exist until the surrounding subroutine is invoked. I'll say that one more time. A local variable, in this case indicated by local and then the name of the variable does not exist unless the subroutine is invoked. Yep.
So wouldn't that mean that the variable would disappear once you exit the subroutine?
But we have seen stuff like that already. It's kind of like the return line number. You don't allocate a column for it until you need it. But when you don't need it anymore, you deallocate the column. So it is the same concept, except this time it applies to a variable instead of just a return line number. So we'll take a look at the mechanism here. We still start execution on line 17. X gets a value of 0. And then on line 18, we will still do the same thing as before, which is to allocate the leftmost available column, label it return line number, and then indicate where we're supposed to go back to. We still do that, but then there's one more thing that we have to do, because now we have to look into the subroutine that we're invoking and ask, does it have any local variables? Yes, it does. Okay, loop 2 has one local variable I. So what we'll do is we'll also allocate a leftmost available column for that local variable I, and every variable should start with an unknown value, so it starts with a question mark here as well. This is something that's new, but it is also not completely new because we have been doing this with the return line number all along. Okay, until you need it, you don't allocate a column for it. And in this case, we're applying it to a local variable. We don't need I until we invoke the subroutine. So when we invoke a subroutine with a local variable I, we better allocate another column just for that local variable I. And then we continue execution from an invoke statement just like before, except line 10 is not traced anymore because it really doesn't do anything. So we now start with line 11. Line 11 says I gets 0. Okay, this I is referring to the I that we just allocated. And then on line 12, we compare I to 2. I is 0, 0 is less than 2 is true. And then on line 13, we invoke loop 1. Same thing as before. When you invoke a subroutine, allocate the leftmost available column for return line number. Line 14 is logically following line 13, so we'll use line 14 as our return line number. But this time, we also have to ask, does loop 1 have a local variable? Yes, it does. Okay, it has another local variable I. Same thing. Okay, if a subroutine has a local variable, allocate it when it is invoked. So we will allocate G, which is our leftmost available column, for local variable I again, and then this time we'll make it a question mark again. So at this point, okay, and then we'll continue execution on line 3, which is the first line in the subroutine that does something. So at this point, it looks kind of confusing because we have column E and column G both labeled I for local variable I. So when we get to line 3, which one am I going to change to 0?
Loop 1 I.
The loop
G?
1I, which is column G, exactly. That is because it is local to the subroutine. It's not only local to subroutine loop 1, it is also local to this particular invocation of loop 1. Now, the whole aspect of it is local to an invocation is not going to be significant until we get to recursion. Okay, but on line 3, it is column G that is getting a value of 0, not column E. So you can see that this time, things are quite different because now we do have 2 columns keeping track of how many times we have to go through a particular loop. Yep.
Can't you just say that it's the rightmost active column?
It's the rightmost active, assuming your program compiles correctly, yes. Yep, that's the other way to look at it. So when we get to line 4, we are comparing column G to 2. So that is also true. And then when we get to line 5, it is column G that is incremented by 1, not column E. So this time we don't have the same problem as before, because the problem that we had before was there was only one variable I, and we trashed it in loop 1. Loop 2 got a basically trashed or modified value. But this time column G and column E are different for one thing, and then column E is not even accessible in loop 1, so we don't have the same problem as last time anymore. When we get through the loop inside loop 1, it's the same thing. X gets incremented here, and then we go back to line 4. I is now 1. 1 is less than 2 is true. We go to line 5 again. We add 1 to I. I goes from 1 to 2. We go to line 6. X gets incremented from 1 to 2. And then we go back to line 4. I is referring to column G. Column G has a value of 2. 2 is less than 2 is false. So we get out of the loop, we get to line 8. On line 8, we have to look up the rightmost active return line number, which is column F. It tells us to continue execution on line 12, on line 14, and then we have no use of this column anymore. But hold on a second. Instead of just deallocating the return line number, we also have to deallocate the local variable. Okay, so both the return line number and the local variable are now on a per invocation basis. When the invocation is done, we deallocate both columns. So in this case, instead of just having one column deallocated, I'm having both columns deallocated here, and I have to indicate that both of these are now deallocated. In other words, I use strike through for both columns, both return line number and I corresponding to column F and G are now deallocated. Are we still doing okay so far? Okay. The rest is actually, about the same thing, but we are now on line 14. On line 14, last time we were incrementing from 2 to 3. This time we don't have that problem anymore, because this I is local to this invocation of loop 2. It still has a value of 0 by the time we get to line 14. So when we are done with line 14, it becomes a value of 1. So when we get back onto line 12, I, which is now column E, is less than 2, is still true, and the rest, the other iteration would basically be the same when we invoke loop 1. Are there any questions at this point? We're running out of time, but this is really the essence of a local variable. Yep, go ahead.
So when you would invoke the subroutine with I again, you have to invoke, put down the variable, have to go with it? Because the variable wouldn't change, the local variable.
You basically have to redo everything from row 8 all over again. So you will still use a question mark to indicate the local variable I of loop 1 has an unknown value to begin with.
So it would reset the value?
Technically, it's not reset, but right after you deallocate a column, something else can come in and make use of it. So even though in this case it seems like it should still have a value of 2, that value cannot be guaranteed. Or at least in theory cannot be guaranteed.